Hi, my name is Luke, and today I'm going to be taking you through a practice calculus problem. This one's called Thinking Outside the Box. It reads, a rectangular piece of metal, 50 centimeters by 20 centimeters, is used to make a rectangular box with an open top by cutting congruent squares from the corners. Determine the dimensions of the box with the largest volume. So, we have a rectangle with dimensions 50 centimeters by 20 centimeters, and we are cutting out the corners with squares, and we want to figure out how we can get to the largest box this way. So in terms of volume, the volume is going to be length times width times height. And in order to find those values, we can look here. We can let's call this side of the square x, which gives us the length and width values for the sides of the box as well. So if height is x, that makes our width 20 minus 2x for these two, and 50 minus 2x here. So our volume is equal to 50 minus 2x times 20 minus 2x times x. And we can take that value and we can expand it, which gives us 4x cubed minus 140x squared plus 1000x. Now, in order to find the optimal dimensions of our box, what we're going to want to do is figure out the maximum value of x, which in order to do that, we need to find the derivative of x. So our derivative of dv over dx is equal to 12x squared minus 280x plus 1000. Now we're going to set that to 0 in order to find our max and min points, which is going to be x plus 1000. We can divide all these numbers by 4 to simplify it. We can get 3x squared minus 70x plus 250. And then I can take this value here and put this into the quadratic formula in order to find our x value. So that is going to be negative b plus or minus the root of b squared minus 4ac all over 2a. We can put our values in from our equation here, which is going to give us 70 plus or minus the root of 70 squared minus 4 times 3 times 250 all over 2 times 3, which is equal to 70 plus or minus the root of this 70 squared is going to be 4,900 minus 4 times 3, 12, 12 times 250, 3,000, so 1,900 all over 6. Now I'm just going to take this and put this into a calculator, starting with 70 plus. We'll start with our plus here. Putting that into a calculator gives us x is approximately equal to 18.93. So we can check this x value by putting it into our width equation here. So 20 minus 2 times 18.93. And by looking at this, we can simply tell that 2 times 18.93 is going to be greater than 20, which means this is going to be less than 0, which makes it inadmissible because we can't have a negative value for width. That's impossible. So let's move on to our value we get when subtracting 70, which is going to be x is approximately equal to 4.4. If we check this again, we check 20 minus 2 times 4.4. That's obviously greater than 0, so we're good there. However, we do need to see what kind of point this is. Is it a max point or is it a min point? So in order to do that, we'll get the derivative of a value before 4.4 and we'll get one after. So dv over x, where dv over dx, where x equals 4, will be equal to our derivative here with x is 4. So we can say 12 times 4 squared minus 280 times 4 plus 1000, which is going to give us 192 minus 1120 plus 1000, which is going to come out to 72, which means our x value is increasing before our point. Now if we check dv over dx when x equals 5, that gives us 12 times 5 squared minus 280 times 5 plus 1000, which is going to be equal to 300 minus 1400 plus 1000, which is equal to negative 100, which means our x value is decreasing after our max slash min point, which means that this is a max point, which means we found our x value, our max x value. So the only thing left to do is determine the dimensions. So we're going to take this x value and we're going to put it into our length, width, and height equations. So first we have 50 minus 2 times 4.4, which is going to be 41.2. We have our width, which is going to be 20 minus 2 times 4.4, which is going to be 11.2, and we have our height, which is going to simply be 4.4. Now, the only thing left to do is write a therefore statement. Therefore, the box with the largest value the largest volume, we'll say, will have dimensions length equals 41.2, width equals 11.2, and height equals 4.4. And that is it for that problem. Now, to make sure you are paying attention, I have one little question for you. What units are these going to be in? Anyway, thank you for listening.